Hello, everyone. Can you guys hear me? OK. Wait. Testing, testing. OK. Hello, everyone. While they get my slides running, I'm going to, I guess, introduce myself and a bit of why I'm here. So, hello, Denver. My name's John Adler. I'm here on behalf of Celestia Labs. I guess a bit about myself and my background. I'm one of the co-founders of Celestia Labs, where we're building Celestia, the first modular blockchain network. I'm also one of the co-founders of Fuel Labs, which is building the fastest modular execution layer. So as you can see, I'm a bit quite excited about this whole modular blockchain paradigm, which is a lot of what I'm going to talk about today. Is it working? There we go. OK. And specifically, what I'm going to talk about is secure off-chain data availability for rollups using Celestia. Let's start. So what's a rollup? Very brief introduction, because I'm sure most of you have already had pretty vast exposure to rollups. You know, they've been all the rage in the Ethereum space for the past few years. So what is a rollup? First, we start with this layer here. This is Ethereum, right? Ethereum acts as the consensus layer, where it performs 3 tasks in this rollup paradigm. It performs data availability, settlement, and also it does execution. What are each of these 3 things? So data availability is essentially making sure that the data behind some transactions has been published to the world. You need this because if you don't have this data, you don't actually know what's happening in the blockchain. In addition to this, Ethereum also provides settlement. So this means it'll verify proofs of what happens in a rollup. It'll verify either that something invalid happened in the rollup, or it'll verify that the rollup is valid. And these are fraud proofs and validity proofs, respectively, and the 2 flavors of rollups being optimistic and ZK rollups. OK, so on top of this consensus layer, you have the rollup layer. And this rollup will do execution. It won't do data availability or settlement. It'll defer those to Ethereum, and it will just perform execution. And there's a variety of examples of rollups: Fuel, Arbitrum, ZK Sync, and there's many more. OK, so how does a monolithic blockchain look like? And this is the traditional blockchains that we've had for the past 10, 12 years or so, or whatever, right? They've all been monolithic blockchains. Monolithic blockchain, in the base consensus layer, at the most base layer, does all of data availability, settlement, and execution. And usually, settlement and execution are tied together. Now, what's the problem with this? The problem is that if you do all these things at the base layer, you're doing a bunch of work. And if you have to do a bunch of work, that work kind of limits the capacity of the system. It limits the total throughput. And this is why many blockchains are now moving towards the modular blockchain paradigm. For example, Celestia and Ethereum 2 are based on this modular paradigm, where the base consensus layer only does data availability. In other words, it makes the transaction data available, but doesn't execute it. On top of this, you have a settlement layer. For example, this could be Ethereum's Ethereum virtual machine. And usually, in the ETH2 model, for instance, these 2 would be tied together. And then on top of this settlement layer, you have a completely separate execution layer. And these can be the same rollups that we've seen before, things like Fuel, Arbitrum, ZK Sync, many others. And the reason that this model is so good is because now the base consensus layer does not have to be burdened with doing settlement and execution. It can just focus on data availability, and therefore it can provide a much higher capacity of data availability by specializing in this. And then on the flip side, execution layers and settlement layers, by specializing only in settlement or only in execution, can provide a much better experience, much higher throughput for those things through specialization. OK, so how would rollups look in a modular blockchain stack as opposed to a monolithic blockchain stack? They could look like this, which is what we saw on the previous slide. It could be that you have one data layer one settlement layer, and then one rollup, one execution layer running on top of this. But you don't just have to have one rollup. You could have multiple rollups or multiple instances even of the same rollup. There's no reason you can't have 1, 2, 3, 10, a million rollups running on top of a modular blockchain stack. So it could look like this. Alternatively, you could skip a settlement layer altogether and essentially have the execution layer run directly on top of the data layer. And this is what we like to call a sovereign rollup chain. This gives you the nice property that since you don't have to provide proofs to a settlement layer, it means the execution layer is its own settlement layer and can therefore decide on its own rules, hence sovereign. The way this looks like practically is that this execution layer here in this model could actually hard fork or soft fork. In other words, change its consensus rules, change which blocks are valid or invalid. And it could do this without affecting the data layer, because the data layer doesn't interpret transactions, it doesn't execute transactions. It just orders zeros and ones. Without having to post proofs to the data layer, but by only using the data layer for data, this allows the execution layer to be sovereign. OK, so what is Celestia, and how will it provide, going to the topic of the talk, how will it provide secure data for rollups? So Celestia is again, it's the first modular blockchain network. It spearheaded this whole modular design paradigm revolution that everyone is now pivoting towards. It's a layer that only does data availability. It does not do settlement, hence the little cross here. It only does data availability. And this is different than, I think, probably every other chain that is kind of trying to be modular, but is actually semi-modular, where they still do settlement and data in the same layer. Here, Celestia only does data. What this means is it can be highly specialized for this one task and can provide many orders of magnitude more data throughput than you can get out of a monolithic blockchain. OK, so what's a Celestium, which is kind of we can finally get to the topic of this talk. A Celestium is essentially taking the best of both worlds from Celestia and Ethereum and using them together synergistically. Where Celestia can provide highly scalable data availability throughput, and Ethereum can serve as a settlement layer and a liquidity layer, because as we all know, Ethereum currently has the strongest liquidity moat. It's the most liquidity out of any other blockchain, especially like programmable money blockchains or smart contract blockchains. It has the most by far. So this allows applications on Ethereum to leverage what Celestia has to offer. OK, so what does the Celestium look like in practice? You have a execution layer, just like you had before, which you can think of like a rollup. Right? So you could have 1 or 2 or however many you want. And then rather than using Ethereum for both settlement and data availability, this execution layer uses Celestia for data availability and uses Ethereum for settlement. In other words, it'll post its rollup block data to Celestia, where the Celestia chain will guarantee through its consensus protocol that this data is available. And users can verify that this data is available through the Celestia protocol, which uses this novel technique called data availability sampling that allows any node in the world to verify that data has been published without fully downloading that data. I don't think any other blockchain does this, or even close to this. Other blockchains, especially monolithic blockchains, require you to fully download data in order to verify it's available, which is part of the reason why monolithic blockchains aren't very scalable. In this case, Celestia, through its data availability sampling, allows anyone in the world to verify that data is available without fully downloading it. And then this Celestium, this rollup essentially, would use Ethereum for settlement, which means it would post fraud proofs or validity proofs to Ethereum to adjudicate, to handle deposits and withdrawals of tokens. OK, so how is this accomplished? It's accomplished through this new technology that we're developing. This is all public and open source. The entire Celestia stack is public and open source. This isn't like some secret thing that we're hiding. It's all out there. This quantum gravity bridge technology works as follows. that you have your rollup here listed as an L2 operator. You have your rollup, and it does two things. One is that it will produce some sort of proof or some sort of claim or attestation on what happens in the rollup. In other words, the effects of the transactions. And then simultaneously to this, it will also post the actual transactions that cause that effect. Right? And again, these two things don't have to be placed in the same layer. You can use different layers for each of them. You can use a separate data layer and a separate settlement layer. And this is what this does. So the transaction data, which you can see on the right here, gets posted to Celestia, and the Celestia validator set will attest to the availability of this data. And if you do not trust the Celestia validator set, as I said before, anyone can run a node to verify that the data is available or not, and it can verify this without downloading all the data, thanks to data availability sampling. Then this attestation, these signatures over the fact that the data has been published to Celestia are relayed to Ethereum through our quantum gravity bridge contract in the form of a data availability attestation. And then downstream rollup contracts can use this bridge contract to query for the existence of a valid attestation. Essentially, it's like a light client relay. This is a fancy light client relay. So in this scheme, rollups will post their proofs to Ethereum and post their data to Celestia. And the bridge contract is essentially a drop-in replacement for a data availability mechanism, which traditionally rollups will either post their data directly to Ethereum, so it can replace that, or some rollups have used a technique called Validium, where you actually leave the data off-chain, but you use something called the Data Availability Committee to attest to the availability of the data. Now you might say, well, why don't I just use a Data Availability Committee? Why would I go through all this hassle of using an external consensus layer instead of just 7 guys, 7 large corporations signing off that data is available? The issue with a Data Availability Committee, and what we're trying to avoid, is that a committee has no penalty for lying. So if the committee lies, and they attest that data is available when it's not, they don't actually get any penalty. There's no penalty whatsoever. They just get away scot-free. The only penalty, if you want to call it that, is the reputation gets hurt. That's not exactly very robust. In this case, if the Celestia validator set lies about data being available when it's not, they will get slashed. This is a slashable offense in the Celestia consensus rules, which means potentially billions of dollars is getting burned through the slashing. That's a very strong crypto economic guarantee. The second reason that the Celestium and quantum gravity bridge approach is superior to a vanilla data availability committee is that with a data availability committee, users cannot verify that the data is published. They have to completely trust the committee, or they have to fully download the data, which kind of defeats the whole purpose of some external person attesting to the fact that data is available, if you have to fully download it yourself. With Celestia, users can actually use data availability sampling to verify the integrity of the bridge before using it and even during using it. So at any point, they know if the bridge is compromised, and then they can enforce the slashing conditions on Celestia. With the Data Availability Committee, you don't actually know that the committee has been compromised. They've compromised you, but you don't actually know it. So this is strictly better than a Data Availability Committee in those two axes. Okay, so now okay, this is more secure than a Data Availability Committee, but why would anyone use this scheme over just using Ethereum for data availability, right? Well, it's largely the same reason why people use data availability committees and why all these rollup projects are exploring alternative data availability options because of this chart. Sorry. If you post data to Ethereum, you're looking at something like a swap being $2 on a good day with low transaction fees. This was taken this morning, or maybe last night. No, this was taken this morning on l2fees.com, made by David Mihal, I think. So even on a good day with not too bad transaction fees, a swap on a rollup that posts data to Ethereum will be $2. If you use an external data availability solution like Celestia, that cost essentially drops down to nothing. It's just a fraction of a penny. So this is why Rollups have been exploring off-chain data availability solutions this whole time, because these costs are simply not sustainable. They're going to get worse over time as Ethereum gets more congested, because there's such a strong demand for Ethereum in block space, and that demand will only increase as Ethereum gains more adoption. We need a solution, and posting all the data to Ethereum, even if you try to do some fancy compression stuff, you're still going to get numbers like this, and it's only going to get worse. And Celestia, through Celestium, through the quantum gravity bridge, offers something that's essentially as secure as Ethereum, but that provides you the low cost of a data availability committee. OK, so if you'd like to find out more, here's our website, celestia.org. Our GitHub is the Celestia.org handle. Again, all of our core code is public and open source, free and open source. Nothing is done behind closed doors. And if you'd like to follow us on Twitter, it's the Celestia.org handle. And also, as a disclaimer, there's no token sale going on, so if you see any of that, that's a scam. Now, we have a few minutes left. I don't know if questions are allowed, but if they are, then we have a few minutes for any questions.
Can you quickly explain how a fraud proof or contesting a fraud proof would look like in a Celestium world?
Yeah, so in a Celestium, well, first of all, let's take a step back and consider a fraud proof in an optimistic rollup, right? In an optimistic rollup, the fraud proof is posted to Ethereum and adjudicated and resolved on Ethereum. In a Celestium, exactly the same thing happens. The rollup will still post its fraud proofs to be executed on Ethereum. The only thing it does differently than a vanilla rollup is that it'll post the transaction data of the rollup to Celestia. But the fraud proofs for an optimistic rollup and the validity proofs for a ZK rollup are still verified on Ethereum, exactly as they are today.
So can you also query data, which was posted into Celestium, or is just does an availability check and then it just discards the data?
OK, so I think the question was, can you query the data that's in the Celestium? OK, so the way it's currently constructed is that every single byte in a Celestia block is attested to via the data availability attestation in the quantum gravity bridge. So you actually get access to every single byte that's in the Celestia block through a Merkle root. And then you can later on provide Merkle proofs against that Merkle root.
How is Celestium's data availability more cheaper than using it over L1s? What makes it more cheaper in general?
So the question was, why would a Celestium be cheaper than using any alternative L1, right? The reason it would be cheaper is because Celestia is specifically designed for data availability, which means it can provide more data availability throughput than any other blockchain in the world. More capacity means cheaper transaction fees.
Can you elaborate on why that happens? What?
Well, it happens for two reasons. The first reason that Celestia provides more data throughput than any other chain in the world is because it doesn't do execution and settlement. By not doing those things, it essentially frees up consensus nodes to just spend all their resources on bandwidth, all on data availability. Therefore, they can do more of that, because they don't waste resources doing execution. That's the first reason. The second reason, compounding this, is that Celestia uses data availability sampling so that nodes can verify that data is available without fully downloading it. This allows you to have trust minimized light clients, and it allows you to have nodes that contribute to the security of the network without being full nodes, without fully downloading everything. And the combination of these two properties is what allows it to have a much higher throughput. OK, no more questions, sorry. But you can find me after. I'll be around. Thank you so much.